Hello there. In this video, we will talk about Boolean logical operator. More specifically, these are the operators that we will cover in this video. But before we get started with these operators, let's recap a little bit and let us talk about operands, operators, unary operator, and binary operator. Now, we already know what an operand is, right? Operands are the values that operator works on, and operand could either be a literal or a value that is stored in a variable. Now, coming to operators, they are the symbols that perform operation on data, or if we say it in another way, they are the symbols that perform operation on operands. And operators could either be unary operator or binary operator depending on how many operands that they work with. Unary operators are the ones that works with one operand, and binary operators are the one that works with two operands. Minus could be an example of both. We know that if we use minus with just one operand, for example, n, what will happen is whatever is contained in n or whatever value is held by n will be negated. If it is say 5, it will become minus 5, and if it is minus 5, it will become plus 5. Now, if we use minus with two operands, for example, m and n, and we say m minus n, we know what's going to happen, right? If m contains say 10 and n contains 5, it will give us 5. So with this done, let's proceed and discuss the first set of Boolean logical operators. Here, we're going to talk about four operators: logical AND, logical OR, logical XOR, and logical unary NOT. Now, let's start off with the logical AND operator. The logical AND operator is a binary operator, which means it needs two operands to work with, right? Now, when we talk about operands, we are actually referring to either the literal or some data stored in some variable. Either way, that data will have a type. And Boolean logical operators, as the name suggests, works with Boolean data, which means the ampersand that you see over here, which is called logical AND, will work with Boolean data. So if we have two variables, say A and B, the type of A and B should be Boolean if we are going to use the logical AND operator. With this discussed, let's talk about what will be the output of A logical AND B on the basis of the values that A and B contains. So we know that A and B will be Boolean, and we also know that there are two literals in Boolean, and they are true and false, which means A could be either true or false and B could be either true or false. Taking these two, there can be four combinations in total. A is true, B is also true. A is true, but B is false. A is false, B is true, and A is false and B is false. Now, when both A and B are true, A logical and B will give us true. When A is true but B is false, A logical and B will give us false. When A is false and B is true, A logical and B will give us false. And when both are false, A logical and B will give us false. So if you notice, when we go for A logical and B, we will get false if one of the operand is false. And we will get true if and only if both operands are true. Now, I just said that logical AND will work with Boolean operands, right? And we had taken A and B as the Boolean operands to understand how logical AND will work and what output will it give depending on different values of A and B. Now, it is true that A and B will be Boolean operand, which means it can hold either true or false. But this does not necessarily mean that A is being initialized this way, for example, in the Java code, or B is being initialized this way in the Java code. It also means that A is a variable which is getting its value by evaluating an expression. For example, num greater than 5. So if I take num is equal to 6, what's going to happen? A will be true. But if I take num is equal to 4, since 4 is not greater than 5, A will be false. So concluding, With logical AND, we will have two operands, and the type of data in both the operands will be Boolean, which means it can either be true or false. And depending on whether A contains true or false and B contains true or false, there can be four combinations. And out of these four combinations, we get true if and only if both contains true. Otherwise, we get false. Next, let's talk about the logical OR operator. Now, with logical OR, what happens is if A is true and B is also true, the A logical OR B will give us true. If A is true and B is false, we will get true. And if A is false and B is true, we will get true. And if both are false, we will get false. So different from the logical AND, in logical OR, we get true if one of the operand evaluates to true, and we get false if and only if both the operands evaluate to false. Next, let us talk about the logical XOR operator. So if A is true and B is true, what will be the value of A logical XOR B? The value will be false. If A is true and B is false, what will be the value of A XOR B? It will be true. Now, if A is false and B is true, what will be the value of A XOR B? It will be true. And for the last one, where both are false, A XOR B will evaluate to false. So what's really going on here? If you observe, we have got true in two cases and we have got false in these two cases. Now, we've got true when the value of both the operands were different. For example, A is true and B is false. We've got true then, and we have got true again when A was false and B was true. But if both the operands evaluated either to true or false, we got false. So this is how logical XOR works. If both the operands are different, it will give us true. And if both the operands are same, that is, they evaluate to the same value, we will get false. So with this, we're done with logical AND, logical OR, and logical XOR. Now let's talk about logical unary NOT. And as the name suggests, it is a unary operator. That means it will work with just one operand. And that operand, of course, will be Boolean. So let's see how logical unary NOT works. Now, taking just one operand into consideration, it can have either true or false, right? So if A is true, not A, or logical unary not A will be false. And if A is false, not A will be true. So it is pretty simple and straightforward. If A is true, not A will be false. And if A is false, not A will be true. So with this, we complete these four operators. Summarizing, in the case of logical AND, we will get true if both are true. Otherwise, we will get false. With logical OR, we will get true if one of them is true. And we will get false only if both are false. With logical XOR, we will get true if the operands evaluate to different values. For example, one is false, the other one is true. And we will get false if the operands evaluate to the same value. For logical unary NOT, true will give false and false will give true. Now let's move to IntelliJ and let's see all of this in action. So we have a Java file over here called Boolean logical operators, and we have a class with a main method. So let's get started with the code. We'll keep it simple. We'll just say Boolean say A is equal to true, and we'll say Boolean B is equal to true. And what are we going to do is we are going to have another variable, say result, where we'll say A ampersand or the logical and B. And lastly, we will print the value of result. Now, if I run the code, we get true. But if I change B to false and then I run the code, we get false. If I change A to false and B to true, I get false. And if I change B to false, I get false. So in short, if we have four println statements, the first one printing the value of true and true, the second one printing the value of true and false, then the third one printing the value of false and true, and the last one printing the value of false and false, and I run the code, I get true in the first case and false in all of the other cases, which is exactly what we had discussed. For logical OR, if I change all of the ampersand that we have to the logical OR operator, and then I run the code, what do we expect? We expect the first three to be true, because in the first three print statements, we have at least one true. And only in the last one, we have got no true, that is, both are false, which is why it is evaluating to false. Next, let's quickly change the logical OR operator to the logical XOR operator. And let's run the code. But before we do that, pause for a moment and let me know in the comments what the output of each of these println statements be. So let's run the code and see if your output matches what IntelliJ is printing. So for the first one, we have false. Next two, we have true. And the last one, we have false. The first one is false because both operands are same. That is, both are true. The last one is also false because of the same reason. The second one and the third one is true because both operands are different. And that is how logical XOR works. For discussing logical unary NOT, let me quickly change the println statements. So if we run this code now, what do we expect? We expect the first one to be false and the second one to be true, because the first one was true, not true, made it false, and the second one was false, not false, made it true. Now, another important point to discuss is these operators can be used together in an expression. For example, if I say A and B, it is perfectly fine, right? But I can also say not A and B, or I can say A and not B. I can also say, for example, not A XOR not B, or maybe A and B or C. And in this expression, I can change B to, let's say, not B. Even this is fine. I can also go for A XOR, say, not B and C or D. All of these expressions that you see are valid. And if you would have noticed, we have used ampersand or the logical AND, the logical OR, and the logical XOR operators along with two operands. But the NOT operator has been used only with one operand because, as we know already, logical AND, logical OR, and logical XOR are binary operators, and the NOT operator or the logical NOT operator is a unary operator. Now, what's going to happen if we have an expression like this, for example? How do we solve it? How do we evaluate it? We will discuss this, but towards the end, because evaluating an expression like this involves the knowledge of something called precedence of operator that we are going to discuss in this video after we have covered all of the operators that you can see here. So for now, let's summarize whatever we have discussed so far and let's move on to the next set of operators, and they are the short circuit OR and short circuit AND. Now, if we come back to this table and if we take a look at these two columns, what can we observe? For A, logical and B, we can observe that if this one false, irrespective of what the other one is, the result will always be false. And it will be true if and only if both are true. A similar conclusion can be drawn for logical OR. Over here, if we have even one true, for example, here, here, and here, the result will be true, irrespective of whether the other one is true or false. And it will be false if and only if both the operands are false, right? Which means that in an expression like A, logical, and B, if the first one is false, we know for sure that the answer will be false. But if the first one is true, which you can see here, the answer will depend on what the second operand evaluates to. As you can see, for A, logical and B, if A is true, the answer is true because B is true. But if A is true, the answer is false because B is false. So concluding, for A, logical and B, if the first one is false, the answer will be false irrespective of what the second one evaluates to. And if the first one is true, the answer will depend on the value that the second operand evaluates to. Similarly, in A, logical or B, if the first one is true, the answer will be true, irrespective of what the second one evaluates to. And if the first one is false, the answer will depend on the value that the second operand evaluates to. So as you can see, the first one is false, but when the second one is true, the answer is true. And when the second one is false, the answer is false. So taking this conclusion into consideration, we can say for sure that if we know in case of AND that the first operand is false, there's no need to evaluate the second operand. Similarly, in case of logical OR, if we know that the first operand is true, there's no need to evaluate the second operand or expression, which will ultimately give us a true or a false value. And that is what the short circuit OR and the short circuit AND will help us in achieving. So if you have an expression like, say, A ampersand B, irrespective of what A has, whether true or false, the value of B will be evaluated. But we know that if A has false, B need not be evaluated. However, the logical AND will still evaluate B. Similarly, if you have A or B, irrespective of what A has, B will be evaluated. And we know for this case as well that if A has true, we need not evaluate B. However, both logical and logical OR will evaluate both the expressions. But if we want to skip evaluating the second expression when the first one is false on using and we want to skip evaluating the second expression when A is true on using OR, we can use the short circuit OR and short circuit AND. If we use them instead, what's going to happen is if you have A short circuit and let's say A is true, for that B could either be true or false, and if A is false, B could be true or false. So the combinations are true true, true false, false true, and false false. Now what's going to happen is since A is true, we cannot really determine what the output will be because we know that it will depend on the value that B evaluates to. So when A is true, B will be evaluated because that will determine the output. But if A is false, B will not even be evaluated because irrespective of what the output is, the answer is going to be false. Similarly, if we use A short circuit OR and we take the same combination of true and false values, we will have these. Now over here, if the first one evaluates to true, B will not even be evaluated because irrespective of what B is, the output is going to be true. So let's go back to IntelliJ and see the difference between short circuit OR and short circuit and between the logical OR and logical AND in action. Let's get rid of these statements and let's say we have int numerator and we say 10 and we have int denominator and we say, for example, 0, and I go for s out and I say, or before that I take another variable, I say int quotient is equal to numerator by denominator and I say system.out.println quotient. Now as you can see, there's a yellow line under denominator, and if I hover on this, I can see it says division by 0, but let's ignore that for now and let's run the code. And you can see that we are getting an error and it says division by 0. So what are we going to do now is I'm going to say denominator not equal to 0 and I'll say numerator by denominator greater than 1. Now if I take a variable of Boolean type and do this, Boolean result is equal to, and then this statement, and then I print the value of result and I run the code. What do we get? We get false, and we get false because denominator not equal to 0 evaluated to false. And since the first one was false, the second one was not even evaluated, because we know that if the first one is false, the result will be false. So result got initialized to false and this got executed. And that is why we are getting false over here. But if I change this to, for example, 5, what do we expect? If I run the code, I get true. And this is happening because denominator is equal to 5, which means denominator not equal to 0 is true. Now, when using short circuit AND, if the first one is true, the second expression is evaluated. And when the second expression got evaluated, what happened was numerator by denominator is 10 by 5, which is equal to 2, and 2 is greater than 1. And that is why the first one being true and the second one also being true resulted in the result variable having true. And that's why we're getting true printed here. But if I change this to logical AND instead, and I change this back to 0, let's see what happens. Remember that when it was short circuit AND, we got no errors. But if I change this to logical AND and then run the code, I get an error. And the error is familiar, right? It says division by 0, and this is happening because denominator is not equal to 0, and this was false because denominator is equal to 0. But even then, the second expression was evaluated, which has numerator divided by denominator, and we know that division by 0 in Java will give us this error. So this proves our point. Similarly, you can take an example and see for yourself the difference between short circuit OR and logical OR. So far, we have covered logical AND, logical OR, logical XOR, and logical unary NOT, and we've also covered short circuit OR and short circuit AND. Next, let's talk about these three operators: the AND assignment, the OR assignment, and the XOR assignment. But before we get started, let's recap a little bit. Now, if you remember, we have discussed these operators: the plus equal to, the minus equal to, the multiplication equal to, division equal to, and modulus equal to. So if we generalize this, it is, say, OP or operator equal to. And if I say A, OP equal to B, what will this evaluate to? This will evaluate to A is equal to A, OP, B, which means if I say A plus equal to 5, this will evaluate to A is equal to A plus 5, right? And the same thing holds for minus equal to, multiplication equal to, division equal to, and modulus equal to. Similarly, the AND assignment and the OR assignment and the XOR assignment work the same way. If I say, for example, A and equal to B, this means A is equal to A and B, which means it will evaluate A logical AND B, and it will store the result back in the variable A. And the same thing holds for the OR assignment and the XOR assignment. If I say A or equal to B, it will be this. A or equal to B will be A is equal to A or B. Similarly, A XOR equal to B will be A is equal to A XOR B. So let's see this as well in action. For that, what am I going to do is get rid of all of these, and I'm going to have, say, Boolean A is equal to true, and I'm going to have, say, Boolean B is equal to false, and I'm going to say A ampersand is equal to B. And what am I going to do here, that is before A ampersand equal to B, is I'm going to put two print statements where I'll print the values of A and B, and I'm going to put two more print statements after the A ampersand equal to B statement. And if I run the code now, we get true false and false false. So let's see what happened. Boolean A is true and Boolean B is false, and that is why the first println statement in line number 6 printed true, and the second println statement, which is in line number 7, printed false, because that's what we had stored in A and B. Now when we say A ampersand equal to B, this is A is equal to A ampersand or logical AND B. Now we know that when we have A logical AND B, it will evaluate to false if one of the operand is false. And that is what the case here is. We've got B equal to false, and that is why this will evaluate to false and the value will be stored in A. And that's why the third println statement, which is printing the value of a after this statement has executed, is printing false. And the last println statement is printing false because b had false and the value never changed after that. Similarly, you can go for the OR assignment and XOR assignment and see the result for yourself. And I highly recommend that you do it so that the concept gets ingrained in your memory. Continuing, let's talk about something called operator precedence. And let me explain this with something you are familiar with, that is the BODMAS rule, right? We know what this stands for. And there's a common misconception as well as to what it stands for. A lot of people think that this is bracket, which is true. This is division, which is also true. This is multiplication, which is true again. This is addition and subtraction. And these are true. But a lot of people consider O as off, which is incorrect. O actually is order, which means either powers, for example, x square, x cube, and so on, or roots, for example, square root of x, cube root of x, and so on. Anyway, let's come back to BODMAS. Over here, what happens is we use this BODMAS rule in order to evaluate a mathematical expression. For example, if I have, let's say, 5 plus 3 divided by 2, say power 2 multiplied by, for example, 4. How will you evaluate this? Using BODMAS, what's going to happen is we will see if there's any bracket or not, and we have none. Then we'll see O, which is order, and we can see that there's 1. So this will get evaluated to 4, and we will have 5 plus 3 divided by 4 multiplied by 4. Then we have division. So we'll go for 3 by 4, and 3 by 4 will be 0.75. So we'll say 5 plus 0.75 multiplied by 4. Then we'll go for multiplication, and 0.75 by 4 will evaluate to 3. So we'll say 5 plus 3. Then we'll go for addition, and we will have 8. And since we have evaluated the expression, this will be our answer. Now, similar to how BODMAS helped us over here, operator precedence will help us in determining what the output will be in case we are using multiple operators. So if we have an expression like, say, plus plus a plus b minus c plus d plus plus, for example, you can see that we have got an increment operator, a plus operator, and a minus operator. Now, which one will you evaluate first? To know that, you can take a look at the operator precedence table, and you can see that this is a list of all of the operators starting from the highest precedence all the way to the lowest precedence, where the higher the precedence, the sooner that operator will be evaluated. For example, you can see that plus plus and minus minus, both postfix, has got the highest precedence. So if you have plus plus in your expression, which we do in two different places, this one is prefix because plus plus is before a, and this one is postfix because plus plus is after a. The plus plus, which is in postfix form, will be evaluated first. So this expression will be evaluated first. Continuing, if we see minus minus has got the same precedence as plus plus, but we don't have a minus minus over here, so let's not worry about that right now. Next, we have plus plus and minus minus again, along with some other operators. So that means this will be evaluated second. We also have these operators, but we're not using any of these in the expression that we have taken as an example. We are using plus, but the plus over here is unary, and the plus that we are using is binary. And the same thing applies to minus. Anyway, continuing, the next set of operators are these: multiplication, division, and modulus. So taking a look at the operator precedence table will tell you which operator to use first to evaluate that expression. Or if you take a look at an expression that is in the code that you're working with and you want to understand what's going on, you can do so by evaluating the expression. And to evaluate that expression, you can take help of the operator precedence table. Now, another thing that you are noticing over here is that we've got multiple operators at the same precedence level. For example, let's say that this is precedence level 1, this one is 2, and this is 3, and so on. So what will happen if you have got multiple operators in the same precedence level in an expression. For example, if you have A multiplied by B divided by C, in that case, which one will you go for first? Will you go for A multiplied by B first, or will you go for B divided by C first? Because if you take a look at operator precedence table, both of them are at the same precedence. So in that case, something called associativity comes into picture. Let's talk about associativity. Let's take the same expression to understand what associativity is. So in this expression, we have got division and multiplication, and we know that both of them are at same level of precedence. So to understand how to evaluate this expression, we will consider something called associativity. Now, associativity is a concept in both maths and computer science that determines the order of evaluation of expression when we have multiple operators at same precedence. And associativity could be either left to right or right to left. So let's understand this in detail. Now we have got A divided by B multiplied by C, and we have got two operators both at same level. Since they are at same level, we will have to consider the associativity, and associativity for this would be left to right. Actually, not just for these operators, the associative will be left to right for all of the operators except one. And that one operator whose associativity is right to left is the assignment operator. So when we say num1 is equal to something something, the right hand part is evaluated first, and then the value gets assigned to the variable on the left hand side. But for all of the other operators, the associativity will be left to right, which means if we have A by B divided by C, we will start from the left, we will evaluate A by B first, and whatever is the answer, let's say X, will be multiplied with C, and we will get the final result. Now let's take another example, and you tell me in the comments, how will this be evaluated? Say, I have got A and then this operator, although we have not talked about what this operator does, but let's take an example. All we have to do is determine how will this expression be evaluated. For that, we can take reference from the operator precedence table, and we can see that one of the operators we have used is this, which is here in say level 5, and another operator that we had used is here, which is in level 3. So one is in level 3, which is multiplication, and one is in level 5. So coming back to this example, this was in level 5, this was in level 3, which means multiplication has higher precedence compared to this operator. So this means B multiplied by 3 will be evaluated first, and then this will be evaluated. So summarizing, we talked about precedence and associativity. Precedence determines the priority given to operators, which ultimately defines which operator will be evaluated first when used in an expression. However, multiple operators can be at same level of precedence, and in that case, something called associativity comes into picture. And associativity, as we know, is both a mathematical and computer science concept that defines how operators at the same precedence level are executed. And in Java, the associativity of all the operators except the assignment operator is left to right, and the associativity of assignment operator is right to left. Now with this done, let's see the usage of parenthesis in an expression. And let's take the same example. Let's say I have A and then this operator B multiplied with 3. By the way, this operator is called the left shift operator. Now coming back to the example, we know that B multiplied with 3 will be evaluated first because multiplication has a higher precedence compared to this, and then this will be evaluated. However, for whatsoever reason, we want to evaluate A left shift B first. Can we do that? Well, yes, we can with the help of parenthesis. If we say A left shift B in parenthesis and then we say multiplied with 3, then even if the precedence of multiplication is higher compared to the left shift, A left shift B will be evaluated first, and then the multiplication operation will be done. So parenthesis alters the normal precedence of the operators that you can use in an expression. But that is not all that parenthesis does. parenthesis also helps in clarifying the meaning of an expression. So if we take a complex expression like this, num1 logical or 5 plus num2 right shift num3 logical and say 7. To understand what the output of this expression will be, you'll have to remember the precedence of the operator, and you'll have to know the associativity as well. Now, associativity is the simpler part. Operator precedence, however, is a little more complex. In this expression, plus has got the highest precedence, followed by the right shift, followed by the logical and lastly, logical or. So if I put a parenthesis around plus, and I put a parenthesis around this 5 plus num2, right shift num3, and I put another parenthesis around this 5 plus num2, right shift num3, and 7. And lastly, I put a parenthesis around this. Now it becomes much easier to figure out what the expression will evaluate to if you know the values of num1, num2, and num3. In short, parenthesis serves two purposes. First, it alters the normal precedence of an operator, and second, it makes an expression much more simpler and easier to understand. And lastly, adding parenthesis to your program will not affect the performance. So feel free to put parentheses in the expression that you're using so that it's easier for you to understand and easier for someone else as well who's reading your code to understand. Now let us come back to this expression. I had said that this expression can be evaluated, of course, but to understand what will it evaluate to, you'll need to know operator precedence. Now, having discussed operator precedence, let's talk about this expression. So we have got 4 operators here. And if we come back to the operator precedence table, we can see that the operators that we had used are this, and this. Now, concluding from this, not has got the highest precedence, followed by ampersand, followed by XOR, and followed by OR. So coming back here, not, then ampersand, then XOR, and then OR. Now, all of these operators are Boolean operators, which means they work with Boolean operands, and we have got 4 of them over here. A, B, C, and D. So in order to evaluate this in A, XOR not B, and C or D, first of all, we'll go for not B, then we'll go for not P and C, then we'll go for not B and C or D, and finally the entire expression. Now, as we have got 4 operands, A, B, C, and D, and each of them can take 2 values, either true or false, there's a total of how many combinations? 16. So in order to solve this, what you can do is you can put all of the 16 combinations that can be there and then evaluate this expression by taking the values of A, B, C, and D in that combination. Let me take a few for example. So we have A, B, C, D. There will be 16 combination, but I'll not take all 16 of them. I'll take some of them only. Let's say I take true, true, false, and true. Random values. Now what do we need? I need the value of not B, right? So I'll put a column for not B. Next, I need a value for not B and C. So I'll put a column for not B and C. Next, I need not B and C or D. So I'll put not B and C or D. I'll get not B and C from here and I'll get D from here. And lastly, I need A XOR not B and C or D. So I'll put another column over here and then I'll put the value according to what these evaluates to on the basis of what values of A, B, C, and D that I've taken. So this is how you can evaluate this expression. And this brings us to the end of the video. Summarizing, we talked about Boolean logical operator, where we got to know about the logical AND, logical OR, logical XOR, and the logical unary NOT. Then we talked about short circuit and short circuit OR operators. Then we continued our discussion with the AND assignment, OR assignment, and XOR assignment. And lastly, we talked about operator precedence, associativity, and using parentheses in our expression. So I hope I've been able to teach you something new and useful. If you have any suggestions, feedback, or queries, feel free to put them in the comments. Thank you so much for watching, and I'll see you in the next one.